So I'm going to give you a 5-minute intro to InSpec. So, oh, it's mine now, okay. All right, yes, so I'm Mandy, there's my contact info. What we know at Chef is that every business is a software business. If it hasn't already gotten there, it's getting there, whether it's education or healthcare or airlines or transit or anything else. Software is becoming more and more important to most places in the economy. So we've been working with security and compliance as projects with our customers. We know that our compliance people work with these big, long PDF files. Security folks have a lot of shell scripts that they use for fixing things, and everybody else is using something else. So in order to bring these folks all together and something they can all use and consume, we have a project called InSpec, which hopes to be human readable and give you a place where you can test your infrastructure for compliance and things that you need. So for something like, say, SSH, where you have a security requirement, a compliance requirement that says it has to always be version 2 instead of whatever else might be configured, we want a good way to test that and also share it with everyone who needs to know about it. So sometimes you have like this life cycle, you get these mandates from security, and it's like, okay, well, it's time for a fire drill, check all your hosts for this particular CVE or a problem that might be happening. And to sort of boil it down into things that we can use not only on the machine, but also share with all of our practitioners, we have something like this particular example of SSH deconfig. I've got enough documentation there that I know what to do with it. It's also going to go through and fix everything. So we use these built-in resources. If you're familiar with Chef, they're very analogous. It works on Linux and on Windows. And it tries to verify all kinds of things on the machine, services, packages, things like that. It borrows a lot of language from spec, like RSpec from the Ruby ecosystem, to be able to talk about characteristics of the things on the system, whether it should be installed or running or disabled or whatever the case might be. It runs mostly as a command line, so you can use it from your workstation or on the machines. It also has a REPL, so you can actually interact with it, which is kind of an interesting way to test it as you're sort of learning it. So we put the test in an RB file, because it's built off of a Ruby base. Make sure we have, if we want to test something about, say, temp, something that should be owned by root and have its modes, things that we would want to be looking at anyway, we create a short little test, describe the file, in this case that it's actually a directory, should be a directory, should exist, should be owned in a certain way, should have a certain mode applied to it. You can see how this sort of builds on the compliance recommendations of sort of larger industry things. So you test any target, run it locally, run it over SSH against a remote Linux system. I can also run it via WinRM against a remote Windows system, and you can shoot it at Docker containers. When I execute it, I just run the test file, the RB file, and it will show me if things were good or bad. Because I want to be able to plug this into workflows or into my Jenkins server or something like that, it returns a 0 return code if everything's good. As you build up more and more of these things, they all sort of relate to each other. You can build up profiles. They can be like industry-specific things or stuff that you write yourself. We publish some that are like CIS standards and stuff like that, and they run the same way. So for something large, like say like this example Linux baseline, it has a whole bunch of controls and a whole bunch of tests in it, and you can see that you can just run one thing and it'll execute across all of them. So we combine this with configuration management to give you sort of a detect and correct mechanism for compliance and security to say, here's my hardening baseline for all my Linux systems, here's what my configuration management then says about fixing all of them. It also plugs into another tool we have called Test Kitchen, which is for fast feedback on your local machine while you're doing local development. So your application developers can also have access to something that they're going to pass security before it even gets pushed into GitHub or whatever. Something new for the latest version of InSpec was that we can also test cloud resources. You can think about people who've leaked things accidentally via something like S3. You can actually use InSpec to test all of the things on your S3 to make sure they're not public. And then there's memorize all those links for all the documentation. There's online tutorials and stuff like that. So.